Welcome back. We'll be looking at two examples today in this video on specific heat capacity. In example 1, we have a small metal block of 74 grams and it is heated in an oven to 90 degrees Celsius. It is then taken out and immediately it is placed in a calorimeter. The calorimeter contains 300 grams of water at 10 degrees Celsius, and the final temperature of the water and the metal comes to 14 degrees Celsius. The question is asking us to calculate the specific heat capacity of the metal block. Looking at the diagram, we have the metal block here of 74 grams and it is heated to 90 degrees Celsius, and we have a calorimeter which has water at 10 degrees Celsius, and the next thing is the metal block is placed into the calorimeter and the temperature rises to 14 degrees Celsius. Now we must note here that this is the final temperature of this system, so the temperature of water and the temperature of the metal block has to be both 14 degrees Celsius. To calculate the specific heat capacity of the metal, we'll use the heat lost by the metal and equate it to the heat gained by the water. The formula that we'll be using is MC delta T. So the heat lost by the metal, since there is no heat lost to the environment, all the heat will be gained by the water. So the mass of the metal is given as 0.74. Specific heat capacity of the metal is not given. The initial temperature of the metal is 90 and the final temperature of the metal is 14. So we have 90 minus 14 on the left side. On the right side we have the mass of water is 0.3 kilograms. Specific heat capacity of water is 4200 and the temperature of water was initially 10 and then it rises to 14, so there is a difference of 4 degrees, and solving this we get the specific heat capacity of the metal to be 896.16. Looking at example 2, we have a metal of mass 100 grams and it is placed in boiling water at 100 degrees Celsius for about 5 minutes. It is then taken out and dropped into 100 grams of water. The initial temperature of water is 20 and the maximum final temperature of water is 26.6 degrees. The question is asking us to calculate the specific heat capacity of the metal. Looking at the solution, we have heat lost by the metal should be equal to heat gained by water, considering that no heat is lost to the surroundings. So we'll again use MC delta T. Substituting the values, the mass of the metal is 0.1 kg, specific heat capacity is unknown, initial temperature of the metal is 100 degrees, the final temperature of the metal is 26.6 degrees, and on the right side we have the mass of water is 0.1 kg, specific heat capacity of water is given, and the initial temperature of water was 20 degrees and the temperature of water rises to 26.6, so there is a difference of 6.6 degrees. Calculating the value of C from this equation, we get 377.66 as the specific heat capacity of the metal. Thank you for learning, and please share your knowledge with others.